All right, 1.2, finding limits graphically and numerically. So we're going to start out with sine x over x. And I want to talk about what's happening at 0. So I'm going to substitute in 0. So what's sine of 0? 0. And then I'm going to divide by 0. So I got 0 over 0. Well, what just happened? It creates a whole. Okay, 0 over 0 is that indeterminate form that creates the whole. Right? What's a number over 0? It's an asymptote. All right? So 0 over 0, in this case, creates the whole. Now, so f of 0 is undefined, true that, but the limit as x approaches 0 is what? What happens when we get close to 0? It goes to 1. All right? So my limit as x approaches 0 of sine x over x is equal to 1. Remember that famous one that we went over? That's the one that we talked about. Now, this leads into our informal definition. This is where we talked about our hands. Let's put them out, put them out, put them out. What's the limit when we do what? Approach from both sides arbitrarily close to a number, a y value number. Now, are they allowed to meet at that number?
No.
Yes. Oh. Yes, they sure can. They're allowed to touch. Do they have to touch for the limit to exist, though? No. Are they allowed? Yes. Do they have to? No. All right. They just have to go to that same number from the left and the right. All right. So that was our informal definition that still is true today. All right. I'd like you to do this graph or this function in your graph. So we're going to talk about the limit as x approaches 0 of x divided by the quantity square root x plus 1 minus 1. I'd like you to put this function in your graph. All right, so go to y equals, put x divided by the quantity square root x plus 1 minus 1. We're going to talk about this numerically, which means with numbers. Now, if I substitute in 0 right now, what do I get up top?
0.
I get 0. What do I get on the bottom?
0.
0. So it creates a what?
Whole.
A whole. Does that mean the limit doesn't exist? No. It can still exist, and that's what we're talking about. So let's figure out how to fill in this table. So go to second, calculate, and then value. And then it says x equals. So the first one we're going to talk about is negative 0.01. And then once you press that in, press enter. And see how it pops out the y equals 1.9949874? So again, in our class, what do we have to round to? 4. At least 4 decimals. All right? Are you allowed to go to more? Yes, but you got to go to at least 4. So that's how we're going to fill out these tables. All right? So you can keep going. Now, I'm going to talk about this. We're just going to say it's filled out. What's it look like it's doing when we're going from the left and the right going to 0? What does it look like it's going to?
2.
It's going to 2. All right?
Yes,
now, did it ever reach 2?
No.
Never reached 2. But we're going to say the limit as x approaches 0 of that function is 2. All right? It's like that little brother or sister says, I'm not touching me. All right? But you know where it's going. All right? So that's it, doing it numerically or with a table called tabular. All right? If we look at the graph, see how when we go to 0, it looks like it's going to 2 from both sides. Pretty good in the hood? All right, let's keep moving. Piecewise function, and it's going to be 1 for everything but at x equals 2. And it's going to be 0 when x does equal 2. And what we're going to find is we're going to find our limit. We're going to find our limit as x approaches 2 of our function. All right, we're going to find our limit as x approaches 2 of our function. So I'm going to look at this graph here. The graph is going to be 1 everywhere but what? But 2. So it's going to be 1 everywhere but 2. And at 2, it's going to have a filled-in dot at what?
0.
At 0.
Dark dots.
All right, a dark dot. All right. But what's the limit? When you do what? Approach from both sides. All right. So when I approach to 2 from both sides, I'm kind of like figuring out where it's going. All right. I'm kind of going in from both sides. Well, what y value does it look like it's going to? 1. So my limit as x approaches 2 of my function is 1. However, if I say, what is f of 2, that's when we're talking about where it's at. Not where we're going, but where it's at. So I'd like to kind of like cover up everything, but where it's at. So what is f of 2? It is 0. All right? So that's a way to think about it. All right? So a limit is where it's what? Going. The value is where it's at. All right, there's a good little nugget for you. So here we go. Let's look at this one. All right. So now I have a limit as x approaches 0 of absolute value x over x. Again, we're going to try to substitute in. What happens? I get a 0 over 0. Oh, crap, that made a hole. We can't do it, right? Just kidding. No. Didn't we do holes on the other ones?
Yeah.
And the limits existed. So now we got to figure out what this is doing. A limit is when you approach from what? Both sides. So let's go negative first. Pick a negative number. -1. I like -1. Let's substitute in -1. What do we get? -1. Let's pick something closer to 0, like -1/2. If I substitute in -1/2, what do we get? We get -1 again. If I do -0.1, it's still -1. It's going to be -1 everywhere except until I get to what? 0. So everything negative is going to be -1 except for at 0. All right? Now, let's go from the positive side of it. So let's pick 1. So what's happening at 1? If I substitute in 1, what do I get? I get 1. And then let's get closer. So like 1/2. What would that be? 1. How about 0.1? What would that be? 1. Everything positive would be what? 1 except for at 0. All right? But what's a limit? When you do what? Approach from both sides. So if I approach from the left and I approach from the right, what happens? It doesn't exist. And you had this last year. So what do we call that? It does not exist because it's a jump discontinuity. All right. I remember that. All right. Pretty good. All right. Let's keep moving. So now let's look at this one. So now I have the limit as x approaches 0 of 1 over x squared. So again, we're going to try to substitute in 0. But what happened here? I get a number over 0. That should be a big old red flag. What happens when we have a number over 0? I get a vertical asymptote. We can almost stop there. Okay, we're not. We're going to keep going a little bit. But what happens when we get a number over 0? We get a vertical asymptote. What happens there? Is our limit ever going to exist?
No.
Never. And what's going to be our reasoning behind it?
Increases
It increases or decreases without bounds. All right? Now, we're going to figure out which one it is. Okay? Because the limit is going from both sides. But we already know, because we got a vertical asymptote, a number over 0, it's not going to exist. All right? And so we're going to look at the numerically what's going to happen. So if I substitute in 1, what do I get? 1. If I substitute in -1, what do I get?
1.
I get 1. And then if I substitute in 1/10, what do I get? I'm getting closer to 0. 100. If I substitute in -1/10, I also get 100. Then what happens about 1 over 100? I'm getting closer to 0.
10,000.
I get 10,000. So what's happening to this?
It's increasing.
It's increasing. they're getting bigger and bigger. So this is meaning my limit doesn't exist because why?
Increases without bound.
It increases without bound. All right? It's going to keep going up and up and up. And I turn to the next slide. Look, you see how they're increasing without bound. All right? They're going up when we're getting close to 0. So that's increasing without bound. Now, if we talk about a reciprocal function, all right? So if I have a function of just like 1 over x, if I do a limit as x approaches 0 of 1 over x, what happens there? That's going to be a what? A vertical asymptote. However, we need to figure out what it's doing there. All right, so we know if we get a vertical asymptote, it's not going to exist. It doesn't exist. But let's figure out what's happening from the left and the right. So pick a number to the right of 0. What's happening?
1.
All right, so 1. So what's that doing?
1.
It's 1. So is that going up or down to the right of 0?
Up.
It's going up. All right, so that one's going up. And then if I pick something to the left of 0, like -1, what's that doing? It's going down. All right, so that's our reciprocal function. So it doesn't exist because why on that one? It increases and decreases without bound. All right. So yes, we know if we get a vertical asymptote, it's going to do an increasing or decreasing without bound, or both. All right. So that one is both. This one, I have a function. Limit as x approaches 0, sine of 1 over x. I try to substitute in 0. What happens? What happens? I have a sine of a vertical asymptote. I have a trig function of a vertical asymptote. Oh my gosh. Alright? What is that junk? So this is what's happening here. If I get closer and closer to 0, first of all, what's sine in between?
0 and
-1
1.
and 1. Alright? It goes between -1 and 1. Now, if I get closer and closer to 0, what's happening to it? It's going from what? 1 to -1 really quick. Alright? And that behavior is called oscillating. Alright? It's like Gloria from Modern Family. It doesn't exist because it oscillates. Alright?
We don't get that.
Limit. Let's review all of them. What's a limit? What does what? Approaches from both sides arbitrarily close to a number, a y value number. Does it have to touch?
No.
Can it touch?
Yes.
Yes. There's basically 4 reasons it doesn't exist. We've kind of talked about 3 of them today. One reason it doesn't exist is what? Jump discontinuity. 2. Increasing, decreasing without bounds. 3. Oscillating. And 4, does anybody remember? At an endpoint. All right, I think textbooks should add that. Why can't you actually have a limit at an endpoint? Because you can't come from one of the sides. All right, so at this one, I can't approach it from the left. I can only approach it from the right. All right, pretty good in the hood? All right, there we go. Homework, go. You could probably finish most of it in class.